Ordered pairs of numbers are used to locate any point on a coordinate plane. Okay, coordinate plane is known as just a graph. The first number is called the x coordinate. The second number is called the y. So if we have an ordered pair like 4 or 5, okay, 4 is our x, 5 is our y. Okay, you guys should know that. This is a refresher. So I'm not going to make you graph this, just pay attention. Okay, 4, 5, we go 4 on the x and 5 on the y. Our dot should be right in there. Okay, it's hard to do with a finger, so give me a break. All right, write this down. A set of ordered pairs such as 2, 3, 3, 5, 4, 1, 5, 6 is what we call a relation. All right, the domain is our x coordinates. So our domain of this relation is 2, 3, 4, and 5. Our y coordinates is what we call a range. So if I ask for the range of the relation, it is 3, 5, 1, and 6. Okay? You need to write all of this down. So this is what we call mapping. Okay? They give us a domain and range, and we draw an arrow from our domain to our range. All right? And you can have some, like 1 and 2 both go to 8. Also, we demonstrate it using a table, just x and y. Okay, our domain is x, our range is y. So we have a graph, a coordinate plane with a bike ride. Okay, we have time as our x coordinate, and we have distance as our y coordinate, or our y-axis. Sorry. I need to know the independent variable. Listen closely. The independent variable is the variable that does not depend on anything. That's why it's independent. Okay? You guys are dependent. You depend on your parents. I myself am independent. Okay? I rely on myself and only myself. So which one of these, distance or time, does not rely on the other? Time. Thank you. Time is always your independent variable. Okay? Does time rely on anything? No. Okay? No, because you can, let's say this person was going on a bike ride and they started a watch. They started right then. Does that depend on anything? No. So our time is our independent variable. Our dependent variable is what? Distance. Okay? Because distance is affected by time. The longer we're on our bike pedaling, the farther we go, right? Okay, so our independent variables always are on our x-axis. Our dependent variables always on our y-axis. All right, now we need to describe what's happening. So you guys describe what's happening. When you're describing what's happening, we look at the graph. Okay, we see that he starts out, he's pedaling at a certain rate, we're increasing our distance. But then what's this flat? What does this mean? He stopped. Time is going on, but is he moving forward? No. So I could say he pedaled for first 10, 15 minutes. He stopped to take a break. Now look at this. Okay? This is a very steep slope, isn't it? Okay? Is it the same steep as this? No, it's much steeper, right? Okay? So if it's a steeper slope, what would you say about his speed? Okay? After his break, he went at a faster pace because in less amount of time he covered more distance. Okay? And then after 5-10 minutes, he decided to take it easy, right? He slowed down his pace. He's still traveled for another hour, okay? But he didn't pedal as hard. So that's how you describe it. He started out kind of fast, took a break for 5 minutes, then really increased the speed, and then kind of slowed down. That's what you describe what's happening. All right, here's your assignment. Cassidy, if you watch this, tomorrow you have to tell me the word hippopotamus, or I will not talk to you.